Okay, so this lesson is regarding Newton's three laws of motion, and it's an introductory lesson. So the learning objectives are that students will be able to identify and explain the three laws of motion stated by Newton with examples in our everyday lives. So first we're going to start off with exactly who was Newton. Newton, or Isaac Newton, was a physicist and mathematician that developed the principles of modern physics. So yes, this does include the three laws of motion that we're going to learn today. He was also the first person who said that white light was composed of all colors within the spectrum. And his first major achievement was creating a reflective telescope, and he used this telescope to study optics and help prove his theory of light and color. His knowledge and theories were questioned by many, including Robert Hooke, a famous scientist within the mechanics and optic field. He passed away at age 84, but obviously his legacy and his theories lived on forever. So before jumping into the three laws of motion, we are going to become familiar with vocabulary words that may come up when you guys study each law. So first is speed. Speed is the distance an object travels per unit of time. So I gave you meters per second. It could also be miles per hour. So these speeds can be converted into any other units. And I'm going to show you an example on the next page because this is crucial for this lesson. Motion is the change in position of an object over time, and it can be described in terms of velocity, acceleration, distance, speed, or time. Acceleration is the rate of change of velocity. So it is measured in length divided by the time, and time is squared. So do not get this and speed confused. You can tell the difference by looking at whether or not the denominator is squared. Velocity is similar to speed, but in velocity, it is a physical vector quantity. So we need the magnitude and direction. And again, there will be an example on the next slide to show you the difference between velocity and speed. Force is a push or pull. It can be external or internal. And gravity is the force that attracts an object towards Earth. So the value given for acceleration of gravity that we will use in math equations will be 9.8 meters per second squared. And then mass is the quantity of matter of an object, regardless of its volume or forces around it. I want to emphasize this is different from weight, so be careful. Weight is affected by gravity while mass is not. And lastly, momentum is the quantity of motion an object has. A lot of the times you hear in sports, oh, that team has a lot of momentum. And what it's really saying is that a team has a lot of motion and it's hard to stop that team. So I want you to take some time to look at these examples and answer what I'm looking for. So the first one is converting speed in meters per second to miles per hour. Again, we need the correct units. The second example is for you to decide what these velocity numbers mean. Again, remember there's magnitude and quantity. So what does the positive and negative numbers mean? Then lastly is to test your knowledge of the vocabulary. Are weight and mass the same thing? Why or why not? Now we will get into the three laws. So the first law states that a motion will stay in motion unless it is acted upon by an outside force. In class, I will be having you conduct experiments to see if this law is true or not, so start brainstorming ideas. So for example, in this picture, you can see that the soccer ball is at rest, and it will continue to stay at rest until some force acts upon it. And in this case, the external force is someone's foot. So as the foot hits the ball moves, and therefore the ball was going to stay in its uniform state of rest, but it was acted upon by an outside force, so its state changed. The second law of motion states that the more mass an object has, the more net force has to be used to move it. A lot of the times you see the equation F equals ma, or force equals mass times acceleration, and it comes from this law. So by the equation you can see if there's less mass, then less force is needed to move it. So in the photo, a stick person is moving a wagon with one block person. And in order for that stick person to move the wagon, the person needs to exert a force greater than the mass of the object. But as more people start to pile on the wagon, the sick person needs to exert way more force in order to move it. The third law states for every action there is an equal and opposite reaction. A balloon is a great example of the third law. When you blow a balloon up and forget to tie it shut, what happens? Yep, it starts blowing all over the room. So in this case, the action of the balloon is the air rushing out of it, while the equal reaction of the balloon is it flying all up and around the room. So in class, we're going to be doing a lot of examples. And I want this to allow you to see how these three laws play into our daily lives when you may not have realized it till now. It literally happens all the time, every day, every second, and you may not even recognize it. So I want you to start forming groups of 3 at the beginning of class and come up with ideas of how you will portray all the laws. I'll be coming around to each group to observe your examples and give guidance if needed. And on the next side is more detailed directions and written forms so you can make sure you understand what we will be doing in class. And at the end of this presentation is a link to the rubric. So I really encourage you to look over the rubric before completing the in-class activity to ensure you cover everything I'm asking of you. And the total points for the activity is 18. So for example, the first law, you will be demonstrating 3 examples that you see in your everyday life. You can do research on this to come up with ideas, and you can also bring in props if you need, but I'll have an abundance of materials as well. So specifically for the first law, you are to come up with at least 2 calculations of speed of the object that is performing the first law. So going back to our example, if you kick a soccer ball, I want the speed of it. So you have to measure the distance it went and the time of how long it took to go that distance. And you must show me all of your examples. So once you come up with your examples, I want you to raise your hand. I'll come around, give you feedback and critiques. And once you are done acting out your examples, you're to post your video on YouTube. So the same goes for the second and third law. Come up with 3 examples of the second law. Come up with 3 examples of the third law. Post all your examples on YouTube, and you must provide an accessible link to our Google Classroom page. So in total, there will be 9 examples, all posted to YouTube, so 3 different videos with 3 different accessible links on our Google Classroom page. So I will see you in class tomorrow. I look forward to seeing all of your examples. Start brainstorming and be creative and have fun. And lastly, the rubric will have a link embedded into this video for you guys to access it properly. Thank you and have fun.